All right. Okay, so for this one, okay, so we're going to solve these two equations, okay? So let's do that. So for the first one, hold on. Here we go. Come on. Okay. So for the first one here, the 5 times x minus 3 stuff, we have this equation that we want to solve, okay? Now, it's not so obvious what the answer is going to be. So let's simplify the left-hand side. Remember, you could simplify either side of the equation. You could do that, and that's actually what I'm doing here. So here what I'm trying to show you is that you can distribute. You could distribute to simplify. So for the first product, 5 times x minus 3, what you can do there is you have 5 times, you could distribute 5 and get 5 times x minus 5 times 3, which is 5x minus 15. Here, you'll have minus 6 times x. Don't forget the minus when you distribute. That's very important. So we have minus 6 times x. And then you have minus 6 times minus 4, which is plus 24. So this is what we get here. This is what we get. So we have 5x minus 6x. So excuse me, sorry, I skipped a line. 5x minus 15 minus 6x plus 24. And now the next line, all I did was I just rearranged the terms so that like terms are next to each other. So it's easier to see what the next step is. So we have 5x minus 6x minus 15 plus 24. And when you combine like terms and all that stuff, you're going to get minus x plus 9. Again, combining like terms, that's all we're doing. Now that was just the left-hand side. For the right-hand side, we have minus 5. So we get minus x plus 9 equals minus 5. So that's what we have here. So now we have this equation to solve. And again, this one's a lot easier, and it's equivalent to this one. Because again, we did the manipulations that we were allowed to use. Excuse me, let me say that again. We used the manipulations we were allowed to use. So this is what we get. Now, from here, we want to get x all alone, right? So we subtract 9 from both sides, and we get minus x is minus 14. But now remember, we don't want we don't want minus x, we want x, so we divide. So we want to get rid of the negative. We can do that by dividing. So we divide by -1. And we get x equals 14. Again, you don't have to do it in exactly this order, okay? It's just one way to solve the equation. Are there any questions on this? Okay, for the next one here, this was the original, x minus 9 equals 9 plus x. So, okay, so let's try and get x all alone. Well, I'm going to add 9 to both sides. I'm going to get x equals 18 plus x, as you can see. Then we're going to have x equals 18 plus x. Well, let's subtract x from each side. I only want x on one side. But what happens, I get 0 equals 18. Well, this equation here is never true. It's always false. This is false. So the original must be false also. So in other words, this one is always false. It's never true. Well, this is equivalent to this one. So this one must be always false as well. So there are no solutions in this one. Or if you go back to that solution set stuff, the original equation, the solution set is empty. So, yeah?
For this one, since there is no answer, would writing x does not equal 18, would that be a sufficient answer?
No, you would just have to say no solutions.
Okay, thank you.
Okay? You're welcome. Again, there are no solutions, so the solution set is empty. So, yeah. All right. Good question. Any other questions? Well, let's keep going then. So in some equations we're going to see, maybe not today, we will have to work with fractions. So I figured it'd be good to go through the least common multiple. You'll see that we're going to actually use it. All right. Now, as a reminder, new terminology. For any integer n, by definition, the multiples of n, those are the numbers of this form. It's just 0, n itself, which is actually 1 times n, 2 times n, 3 times n, and so on. In other words, all you're doing is you're multiplying non-negative integers with n. That's all we're doing. That's how you get the multiples of n, where n is any integer. So for instance, the multiples of 3 are 0, 0, 3, 6, 9, 12, 0 times 3, 1 times 3, which is just 3 itself. This is actually 1 times n, which is n itself. 2 times 3, 3 times 3, 4 times 3, and so on. Then we have this notion, the least common multiple. So if let m and n, they're 2 non-zero integers. 2 non-zero integers, okay? So m and n are not 0. Then by definition, the least common multiple of m and n, the LCM of m and n, is the smallest positive integer that's a multiple of m and n. That's just what it is by definition. It's the smallest positive integer, which is a multiple of m and n. It's the smallest positive integer. It's a multiple of m and n. So 0 cannot be the least common multiple. So for instance, let's suppose we had 6 and 8. There are fancy ways to get the least common multiple. They're based on number theory, so I'm not going to go through them. For now, all we can really do is just list the multiples. List the multiples until we get the first positive integer in both lists. So 0 we actually disregard. Even though 0 is technically a multiple of both, it can't be the LCM because it has to be positive. So we have 6, 12, 18, 24, 30, 36, and so on. Although we can stop here. For 8, we have 8, 16, 24, 32, 24 is in both lists. So because of that, 24 is the least common multiple. 24 is the least common multiple of 6 and 8. You actually can list the multiples until you reach m times n. So we could actually keep on going until we get to 6 times 8, which is 48. Okay, here's another one. Let's look at 12 and 10. 12 and 10. So again, same idea, okay? We're going to list them. 0 I didn't list because, again, 0 cannot be the LCM, the least common multiple. And you really want to stop also once you hit 12 times 10. Okay? So we have 12, 24, 36, 48, 60, 72, and so 84, and so on. We listed for 10 also. But we can actually stop at 60 because you can see 60 is in both lists, right? It's in both of them. So 60 would be the least common multiple of 12 and 10. And you'll see, actually you guys will get to see, I didn't get this far in the other class. You can actually do this procedure for 3 integers, for 3 of them. Okay, any questions? Okay, so how are we going to use this? Well, let's consider this equation. I mean, those denominators are going to be not trouble, but they're going to make things a little tricky, right? So it would be nice if we can eliminate them algebraically. And you can do that. And really algebraically, from the best way to do it is to well, I shouldn't say the best way to do it, but a good way to do it is to multiply both sides by the least common multiple of all the denominators. I mean, really, you can use any common multiple. You could actually use the product of all the denominators, but the numbers can get really big, and then, you know, that could be kind of messy. I mean, it's not terrible, but it is something but it's not how do I say this? The numbers can get really big, and then your answer may not be simplified. So it's generally better to use the least common multiple. So let's get that for 3. So if we want to solve this equation, we want to get the least common multiple of 3, 4, and 6, and we're going to multiply both sides by it. So let's get the least common multiple first. So we have 3, 6, 9, 12, 15, 18. Now I'm going to stop there. Okay, I mean, I could keep on going, I guess, if I wanted to. We have 4, 8, 12, 16, 20. Okay. What about 6? 6, 12, 18. Up 12, we can see, is in fact the least common multiple. I mean, you do have to go far enough out until you get something in all these lists, a common element. So we got 12. So I'm not going to be able to finish this, but what you would do is multiply both sides by 12, both sides of the equation. And what would happen then, as you can see, well, hopefully you can see it here, you would distribute. And what would then happen is the denominators would end up canceling. And now the equation becomes a lot easier once those denominators are not there. You know what, we're running out of time, so let me stop here. So I'm going to have to stop here because we have well, actually, we're out of time. So we'll pick up from here on Wednesday. And again, when the test is posted on Blackboard, I will let you know. All right.